Hello, Dr. Gomet here, and I am doing a video, which tail am I in? Because I think there's a lot of confusion about when do you leave the p-value alone, when do I do 1 minus the p-value, when do I multiply by a p-value of 2. I had a student just the other day, and she just indicated it was confusing, right? So, like, I understand with everything else you're keeping track of, this detail gets lost. So what I wanted to do was present a table and some figures to help you understand when and why you make the changes to the p-value. And so this short video is just to address that. I already have videos on hypothesis testing and what a p-value is, so I want to get really focused today. And it all starts with the alternative hypothesis. This is the one thing that lets you know. The alternative hypothesis tells you where in the distribution you are looking. So if you have an alternative hypothesis where the value is less than, you just care about the less than. It could be a proportion, it could be mu, but you just care about less than. Then you are looking in the left tail for the extreme values. You're over in this left-hand side, okay? If you have a greater than in your alternative hypothesis, then you're looking in the right tail for these extreme values. So you're over here in the right tail, but everything is shaded from the left, right? So how do I get this left tail over here? And then if you have a not equal to, then you're actually looking in both tails for the extreme values. You're looking over here and over here. And so for each of these three hypothesis tests, we're looking at different tails of the distribution, right? So most p-value calculations are actually only done from the left. So how do we fix this, right? If you're doing from the left and you have a less than, that's fine, right? But if you're greater than and you're looking in the right tail and you're only doing from the left, like there's an issue there. And if you're looking in both tails, and really I can only do one tail at a time, how do I fix that, right? So that's what we're doing, okay? So first, for any alternative hypothesis with the less than, you don't do anything. You simply calculate the p-value, right? It's this picture right here. You're in the left tail, you're less than, that's how it gets calculated. All is well in the universe. Don't do anything. Second, for any alternative hypothesis that's greater than, we take advantage of the fact that the entire area under the distribution is 1. And this leads us to the whole distribution 1 minus the from the left is equal to the from the right end area, right? So if I subtract this part from this part, all I'm left with is this. And so that's why we do the 1 minus the p-value for right tails only, for anything that is greater than in our alternative hypothesis. Last, for any alternative hypothesis that's not equal to, we actually take advantage of the fact that the tails are symmetric. And so this leads us to the following. I've got the left tail over here plus the exact same area in the right tail over here, means that that's equal to just twice the left tail, right? And so this is why what we have to do is 2 times the p-value for a two-tailed test. And again, we get that two-tailed test when our hypothesis test is the alternative hypothesis is not equal to. Got it? Okay, so I've got the table here that I promised down at the bottom. So for less than, you're in the left tail, you leave the p-value alone. For greater than, you're in the right tail, and so you do 1 minus the p-value. And for not equal to, that's a two-tail test, and so you do 2 times the p-value. And that's it. It's as simple as that. I hope you enjoyed it, and that makes us happy.